Welcome. My name is Aarno Aukia. I'm here to tell you some tales from the trenches of how we used Crossplane for the things we may or may not should have. My name is Aarno Aukia. I'm co-founder of Vision, the DevOps company based in Zurich, Switzerland and Vancouver, Canada. And I'm happy to take the short train ride from Zurich to beautiful Munich this weekend to come speak to you guys. We're 40 people. We do 24/7 application operations and DevOps support for companies. And of course, that means nowadays that we do a lot of platform engineering. We do that on any infrastructure, physical, virtual, customer on-prem. We use Kubernetes as our standard platform, and we integrate all the tooling we need to do that. So configuration management, backup monitoring, maintenance processes, all of that is wired into Kubernetes so that we can, on top of that, do either 24/7 application operations for custom software, which is what we started with 11 years ago, to provide for software development companies, agencies, software service companies, basically to help them with the 24/7 burden. Right? We're system engineers. We've been doing 24/7 for 25 years. It's okay. It's like firefighting, right? You get into the rhythm, you get used to it, you have your shifts, it's okay. Software developers, if they haven't slept in the night, you can't use them the day after, right? So that's how we can, complement each other just as we build buildings. We have the architects, the software architects. We are more the civil engineers and the firefighters. If there's an incident in the building, thank God there's firefighters coming, and we don't have to do it ourselves, right? Now, in the past few years, we have more and more software product companies that approach us, right? They do software product, want to offer it as a service to their customers. Their customer has their own instance to do it. On-prem, air-gap, they do it. In a private cloud, they do it in a public cloud, wherever they need to do it. That's actually something that now started about 5 years ago for us. And that, of course, uses the same stack for us. But, of course, they have all the same problem of how do we do that somewhere all around the world. And the product we came up with is called Serverla. We launched at the beginning of this year. We've been doing it for 5 years now. It's an open source app store that runs on your Kubernetes, so wherever that is, on whichever infrastructure that is. And that helps, of course, the different software product companies to be able to offer their products on any infrastructure. But also vice versa, it helps the cloud infrastructure companies, IT outsourcing providers, small and medium-sized cloud providers, to have this whole catalog of software. I'm coming back to that in just a second. And then we can offer 24/7. It's an open source project, and then optionally we provide 24/7 support and the 99.99% SLA on the App Store itself, and of course on the running instances as well. Right? So that's kind of our answer to this whole data sovereignty debate. If you want to run you don't have to ship your data to wherever the cloud is. You can get the apps to wherever your data already is. And then if you need an SLA, we're of course more than happy to provide you that. Now, that sounds fun and games. We do that for a few different product companies, from more of the infrastructure side to more of the application level side. And on serverla.com, you have this whole kind of list, which is a Python Django application that you basically can install on that also runs on your Kubernetes. And then when you have the whole listing, you click on one, you have the details. On the public one, you can deploy it on one of the public cloud providers. And on the private infrastructure, you have to have the enterprise private cloud, which you of course can't read because it's too small, that you can then basically deploy on your own infrastructure. Now, when you click on a service, you can set some parameters. If you use the GUI, and of course you see the status. But already here you start seeing like some control plane and some composition stuff, which that sounds pretty Kubernetes-y, right? Which is the whole idea, right? This is just a Python Django frontend for the ClickOps people around us. As we're here at KCD, Cloud Native Munich. And of course, we're used to Kubernetes, right? And of course, we use Kubernetes in the background for that as well. So for example, this is a minimal example of how we provision a Postgres, or how you can provision a Postgres database. Basically, that's the minimum. You have to give it a name. You have to give it the name of a connection secret. And then you get a secret back. And of course, the secret is much more easier to read when it's base 64 decrypted. Sorry about that. But of course, the whole idea is that this is just a web GUI to this API, and then you can use the API directly, of course, as well. So that a part of your application, your deployments, your ingress, you have all the backends, basically the database as well. That's the whole idea of the product. And then we have a documentation of of all the other parameters you can choose, whether that's from backup, restore, security, maintenance, sizing, service level agreement. You can choose deletion protection, storage, la 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 la. There's the whole stuff you can basically then choose. So that's basically the API, kind of the platform engineering API that we as platform engineers provide to the users, and then the users hopefully, or we try to make it as hard as possible for the user to shoot themselves in the foot by only allowing certain parameters, not all parameters, and then you have some checks, right? So if you want to have a high SLA database instances, you have to have at least 2 replicas, for example. And if you try to do high SLA with only 1 replica, the Kubernetes API says no, right? Because that logic is embedded in the API. And so that's kind of these kind of basic checks we can do and tell the user, hey, if you really need an SLA, then really, really please make it at least 2 instances in case of Postgres, right? We do that for all kinds of public clouds and private cloud providers. Maybe not too much about that. And as I already started to teasing, we have basically the serverless web frontend, Python Django, that's also on serverless.com, that basically in the background talks to the same Kubernetes API as can the user themselves. And of course, we use Kubernetes, not only because we're at KCD, but also because it solves a lot of our problems that we need to solve for an API, but already by itself, right? So from authentication, authorization, role-based access control, namespaces, and multi-tenancy, that's already built into Kubernetes, right? We don't have to reinvent that in our own RESTful API. And that, of course, makes it much easier for us and hopefully also for the users to use the API and integrate it into their CI/CD processes or whatever Argo CD tooling they use to deploy the rest of their stuff. And then we use the, surprise, surprise, the Crossplane operator to basically then pick up all of these kind of orders and then deploy them, right? Crossplane by default deploys it on the same cluster as where the order came in. And then we have a lot of customers where kind of the databases or whatever services that they order should not run on the same cluster, but on a separate cluster. So then we have kind of these service clusters where the Crossplane on this cluster then instantiates the actual service on the separate cluster, like next to it, right? So they have some dedicated hardware for that or better storage or whatever. That's basically up to the customer to define why. And then Crossplane, we use Crossplane because then again, solves some problems we had or expected to have, like define the parameters and validation. So the API, right? So what can the user choose? What's the name of it? What's the parameters it has? What is the validation logic for the parameters? Which is in Crossplane logic, Crossplane speech called composite resource definitions, XRDs. Then we define the templates. So once an order comes in, what comes out of Crossplane, right? These are called Crossplane compositions. And then providers are basically then APIs that use to talk to external systems that basically then instantiate stuff, right? And there's, of course, built-in providers into Kubernetes, into Crossplane, like the AWS, Azure, Google providers. There's the Kubernetes provider, the Helm provider, the Terraform provider. So you can basically give it Helm or Terraform or Kubernetes objects, and then Crossplane knows how to roll it out by itself. And then the templates that we write, and they're on our GitHub pages, they include then not only the service itself, so database or whatever, but also the whole logic of how do we do backups, how we do monitoring, how we do alerting, SLA maintenance, schedule, all of that kind of additional logic is of course then added to the template so that the user of the template doesn't have to care or think about the monitoring. And of course, if you would use it now for more infrastructure-specific stuff, you could add like the whole like virtual networking and all of that security stuff. You could also add to this kind of template, which then again makes it easier for the user to do it right the first time instead of make it possibly publicly accessible, for example, by accident. So that's how we built the whole thing. Who has heard of Crossplane? I would say it's over half, over 2/3. Who uses Crossplane in production? That's a good 15% maybe. Excellent. So you have something to learn, all of you. Those, I would say about 40% that do not know what Crossplane is. Crossplane is a CNCF project. It's a Kubernetes operator. It started as, and currently still the primary use case for it is basically to have this open source operator that can instantiate infrastructure. So for example, by default, it includes the AWS provider, the Google Cloud provider, the Azure Cloud provider, and you then give it Kubernetes CRD. I have an example in just a second. I think it's the next slide. And then you can let Crossplane create VPCs and networking and all of this kind of cloud, public cloud, hyperscaler cloud-specific infrastructure for you. And this basically, it's a translation between the Kubernetes config world and the hyperscaler-specific API. That was the initial kind of use case and idea of Crossplane 6, 7, 8 years ago, so quite a while ago, right? Pretty radical at the time. But of course, what since has happened, and of course why we thought that was a great idea, is it kind of evolved in this generic platform engineering, before even the word platform engineering was used, API, right? You can use it to manage any service. It doesn't have to be a hyperscaler service, right? And of course, the whole development on Crossplane has since evolved more and more into how to write custom providers, how to orchestrate your internal systems, how to add your internal systems, custom systems, Kubernetes-based systems, so that you can build this kind of easy for users, or easier for users to understand APIs on Kubernetes, and using Kubernetes as kind of the Drehscheibe, kind of the turning point, kind of the center of that universe, right? I have a few tiny examples. They are in no way connected to me or what we do as a company. They're more to understand like how does this all fit together. So this is again a pretty minimal example of an API. This is like for a NoSQL database. And you have one parameter, which is called location, right? And so if you want to offer this kind of API to your users as a platform engineer, you can do that by writing this, again, Kubernetes config. You don't have to write your own Kubernetes extension server. You don't have to write your own Kubernetes controller or anything. You basically configure Crossplane to offer this API to your users, right? It's a layer of abstraction, which has its ups and downsides. But if you only need this, then this is actually a pretty small and tiny way to do that, right? And this is what is called the composite resource definition. So definition of the API, which is called a composite resource in Crossplane speak. You give it all kind of name and and then you define your own schema. And in this case, the schema has a property, and the property is called location of type string. And here you can already add the kind of validation logic, right? So in this case, the string can be either EU, from beginning to end, no extra white space, whatnot, or US, right? So you allow only these two variants or these two for the parameter of location. And for anything else, Crossplane tells the user, sorry, you can only use these two, right? So that's a way for you to give it pretty bulletproof, right? If they put in Asia in there, Kubernetes says no, right? So this is basically the kind of a minimal example how you can build that using Crossplane. And then, once an order comes in, surprise, surprise, you can use a composition, which is Crossplane speak for kind of the template, right? So you can use it, you can write this template again in Kubernetes config. So if one of these comes in, well, then you create two resources. The first one is an S3 bucket, and then you map EU to EU North and US to US East. And then you actually create a database, in this case an AWS database, and again you map you create the database, and then you patch the database, and you add the correct location to it. Right? So does this make sense? Maybe, not for me, maybe for you. But I mean, this is a minimal example to kind of show you this kind of templating stuff. Now, for anything more complex than creating two kind of AWS-specific Kubernetes resources, which are then picked up by the AWS Crossplane provider, which then actually goes and talks to the AWS API and creates stuff for you, and then gives you back the kind of the status it's actually created, you would write a function. Right? So in this case, and that's actually most what we do, we write it in Golang, which then basically creates, in background, it creates a Kubernetes Crossplane composition function. And the Crossplane composition function is basically a gRPC server that Crossplane talks through gRPC to your logic. You can do anything, you know, as it's Golang. and then you give it the gRPC answer and say, okay, now you please do this, right? So there you can do anything with it, and of course, writing it in Golang gives you a lot of benefits of code checks, analysis, continuous integration, and testing, which is much harder with this kind of Kubernetes YAML templates, right? So there's of course much easier, and YAML being like a totally separate thing anyway. So that's basically then the kind of the level 2 of writing these kind of templates is you write it in Golang and then let Crossplane talk to it via gRPC. And of course, these are all public. They're on a GitHub account, so go feel free and be inspired, right? Crossplane is an CNCF project. It's open source. There's a few companies that provide commercial support. Upbound is the original creator of and sponsor of the project and donated it to the CNCF. They are based in the US. We are based in Switzerland. Aloud is based in Hong Kong, and InfraCloud is based in India, if I remember correctly. So if you have any needs for Crossplane support, feel free to reach out to, of course, any of these. Now, as I mentioned, the Serverlab project, we kind of launched this year. But we've been doing this since February 2021, using Crossplane 0.14 at the time. I think 2 months after we launched production, they came out with version 1. So that's quite a few iterations back. At the time, there were no composition functions. So the only thing you could do was patch and transform, which is you define the Kubernetes object, and then you say, OK, now please change this and that, and please add this and that. And that's, of course, OK for the trivial ones. But as soon as you need like loops or something, you're kind of out of luck. Which means that we started playing around pretty early with the gRPC API. So which are now called the composition functions and actually now are the default for Crossplane. So I guess we left the mark there, but with the need and the use case, why that's used. And as I mentioned earlier, multi-cluster is something that's it's going to come back to in just a second. It's a Crossplane contrib project, the multi-cluster stuff, which is fun, but it's not in the core. And of course, that means it's less tested, there's less people, less attention. It's much more energy needed to basically make it run, keep it running, and making it user-friendly. And of course, since we use it for database service and that kind of stuff, there's a lot of this kind of database automation that we've used. Started first using Helm charts and then migrated to operators and so on. So that's, of course, a little evolution in the past 5 years, as has been with the whole rest of the Kubernetes ecosystem. So since then, there were quite a few things that kind of were, let's say, barely working, but barely working, right? So the whole composition functions, they were alpha. We started already using them, talking directly to gRPC APIs, but they didn't have OpenShift support. We have customers running on Kubernetes, we have customers running on OpenShift, so we kind of needed to support both. So the whole alpha thing was kind of a problem for us to actually use their implementation, so we kind of had to roll our own, which was kind of painful. I just mentioned remote cluster is contrib only, so it has less attention, it's harder to debug, it's less user-friendly. And then, as with everything where you have like define a state, you have like a defined state, you have an actual state, and then you have the actual world, right, that you want to kind of control. There's opportunities for race conditions, right? So there's opportunities for kind of state mismatch, right, where what you think the state is isn't actually what the state is, and it's definitely not the state that it should be, right? And then you wait for the eventual consistency of the actual world converging to the state it should be, and then that being reflected in your documented current state, right? And that, for example, concretely, when you create a service, you get kind of the information from the service back. It was created, it has now this host name and this, whatever information that the service provides. And then you need to basically first get it into Crossplane, and then Crossplane needs to go and create the Kubernetes secret for the user to actually use that. That takes like forever, right? Just that cycle of kind of feedback takes like multiple iterations, and that's kind of painful, right? If the service is running in a few seconds and you have to wait like multiple 30-second iteration loops for that to converge, and you wait like 2 minutes for the secret to get back, it kind of doesn't feel like properly working. And then, on September 11th, of all dates, we had an incident. We had an opportunity to write a 26-page post-mortem afterwards, which happened after maintenance. Never touch a running system, or of course you have to touch them because we do DevOps, right? And after the maintenance, of the 1,500 services, about 230 were left in an invalid state. So the state of the Kubernetes config object did not match anymore the state within Crossplane, and thus Crossplane didn't know if the actual state outside in the world was which one it's actually going to be. And the default for Crossplane at the time was that if the state is invalid, that means the real world wins. Because if you talk to the AWS API, if the AWS API says the database is gone, well, then you don't need the database anymore, obviously, right? And it marks the service for deletion. And the service deletion marking is just, I think, a deletion timestamp. It's a very, small. If it's 0, it's not deleted, and if it's something else, it should be deleted, right? And then one cycle later, the garbage collector comes and sees, oh, this is a service that's not used anymore. Away with it. And there is no way to tell the garbage collector not to collect garbage, which was kind of a problem because we could see like the database is going away like one by one, which may or may not have been a fun thing to have a look at about 2,100 hours with the deletions going on in the background. So that was fun at the time. We were able, most of them were test databases, that the data was gone and wasn't important. A few of them we were able to find the PV, and a few of them had backups. So there was no actual permanent physical harm to anybody or anyone, and it was only happening on one customer private cloud infrastructure. It was one of the biggest customers, a large Swiss telco, but still it was kind of an isolated incident because we rolled out the changes like one by one. So that was, of course, catched. So yeah, that was fun. So now the Crossplane project has been working on, and so have we, of course, on version 2. We're currently still at version 1. Version 2 is now publicly available. There are a few things that are no longer there, like composites or claims. So that's something we're looking forward to because we think it makes it easier. And since we already migrated 100% to decomposition functions, for us, it's very natural, right? As a user that uses composites currently, that's actually not a problem. There's a fallback. So the default composition function is actually the composite function. So no, don't be afraid. It's all going to be fine. But what we actually like a lot is that the focus of V2 is not only manage the hyperscaler cloud infrastructure, but to manage any Kubernetes resource. So it kind of the whole Crossplane project goes into this, hey, this whole platform engineering on Kubernetes for Kubernetes is a thing. And so that's where a lot of the effort of making it easier, making it having more tooling around that has gone into, and of course, since that's exactly the use case that we use, we support that a lot. The only downside is multi-cluster is still contrib, so that part of if you have more than one cluster, that part we still have to put our own energy in, or as a community we still have to kind of add to that. So when I started using Kubernetes in the fall of 2015, summer of 2015, in June actually, I fell in love with it. I fell in love with it because of the declarative, right? I declare, the machine tries to make it real, and if something changes in the meantime, it just keeps on doing that, right? The kind of hard to swallow lesson for me was declarative does not have to mean predictable. Because if there's so many moving parts and layers of abstraction in between, the state propagation can kind of eat into your declarativeness, right? And that was kind of hard to understand for me at the first, because for me, it felt so logic, right? But these are kind of the implementation details of this kind of complex system. And let's be real, Kubernetes is a very complex system. That's the kind of the entry-level barrier, but that's also why it's so powerful, right? And I guess having this balance is something that is a lesson learned for me. And then, of course, deletion protection. Funnily, on the user side, deletion protection is enabled by default. So there's a parameter, deletion protection, true or false. If you don't specify it, it's true. If you want to delete a resource where deletion protection is set to true, Kubernetes says no. The problem is in the background, so the actual instantiation of the service in the real world, there has not been deletion protection. So that's maybe something we have to add as a community project afterwards. That's all I had prepared for you guys. I'm 2.5 minutes ahead of schedule, which means we have plenty of time for questions or other discussions. And even after 2.5 minutes, we're very well in time for lunch. Thank you.
I have a question regarding the scale of Crossplane. On which scale is it really viable? Like how many workloads you can put on a single cluster? As you said, the focus for the tool is the single cluster now, is the same cluster now. How many workloads you can put before you start hitting limits of the Kubernetes itself, like the etcd storage and stuff like this?
Excellent question. So scaling and what are the kind of the scaling limits? So currently we have not yet hit the Crossplane scaling limits with small 5-digit number of service instances per cluster. So 20K, 25K service instances per cluster has not been our Crossplane has not yet been the problem. We've hit many other problems. So, for example, we previously used stackgress operator to provision and manage Postgres instances, and that one reliably falls over above about 250 Postgres cluster instances. And then with that, the whole etcd and Kubernetes API goes down, and well, then you don't have to worry about Crossplane anymore, right? Which is why we're now migrating to cloud-native PG. So Crossplane itself has not been a limiting factor until now. We have experience up until about 20K, 25K service instances per cluster. Thank you. Other questions? There's one up here.
Yeah, thanks for the talk. Considering the architecture that you provided at first, where you have that App Store-like experience at the very beginning, how does your backup and disaster recovery strategy looks like for that multi-cluster setup, considering the overall architecture? So where services are distributed across multiple clusters, exactly this one.
Yeah.
Because you have multiple hops and instances, and doing backup and disaster recovery, I think, might be very hard.
Yes.
Especially consistent ones.
Yes.
So if you need consistency.
Yeah. So we do backups. So each service defines how they can be backed up, right? So for some services, it's pretty trivial. For some services, it's more complicated, like databases and stuff, right? We have written, and we launched it in 2019 at KubeCon Barcelona, the KTUP backup operator. The KTUP backup operator, I mean, you probably all heard of Velero, right? Velero runs on the infrastructure layer. So you kind of take the PV or the volume of the PV and do stuff with that. KTUP has a different approach. It runs in user space, so as a pod on the infrastructure in the namespace of the actual user. And then you have annotations to tell KTUP how you back it up. Should it just take the PVC? Should it run a specific command? like making a dump, or snapshotting and stuff we haven't implemented yet, but it's probably one of the next ones to basically make a snapshot and then back that one up, right? So currently we have dumps of different databases, for example, and we have just the PVC backups, right? And that runs then on for each service instances, it runs wherever the service instance is running. KTAP uses the Restic, 30-year-old Linux backup tool. And then Restic can then write to any, it has like 25 backup targets, like backup storage targets you can configure. We use a lot the S3 storage endpoint, right? So each service instances, it basically backs up to an S3 bucket that then is versioned, and you have the whole archiving and all of that. And then we expose kind of the backup listing and archives through the API of the service. So as a service owner, you can say, give me a list of the backups, and then you say, please restore me this backup, right?
Yeah, but I was referring to the state distributed across Kubernetes clusters.
Sorry, I understood.
So in this case, you have the two clusters.
Yes.
Basically, you have on the Crossplane node on the left-hand side, you have one part of the state, and on the right-hand side, you have the actual service. So if one of those clusters, no matter if it's the left one or the right one, was gone for good, then how do you do restore then? How do you maintain consistency of the state that is distributed by nature?
Absolutely. So you have basically up here, you have the orders, and here you have the actual running instances, right? So if this one goes away, and you make a new Kubernetes cluster from scratch, with the order, you can recreate the service instances. But you don't, of course, have the data anymore, if this one is like, poof, gone, right? Then you have to restore the data from the order, and the order contains the reference to the S3 bucket, where the data backup is, right? And then you have to restore that. But that's not a fully automated process.
Thank you.
Perfect. Any other questions? Oh, wow. We're running out of time. Small questions, quick questions.
So my question is regarding the life cycle of the compositions and the so sometimes we have we update the Crossplane, right? And then we have compositions which are not backward compatible, right? And it's a huge problem, like we also recently faced. So and also a link to this question is the debugging problem. Sometimes there are managed resources which are ready but they're not synced, right? And in the pool of so many CRDs, right, it can sometimes become hard to debug the resources because the actual errors and they are just hidden in the logs. So two questions: how do we handle lifecycle, and how do we debug when we have done the lifecycle management?
Excellent. So the first question is the easier one. Let's answer that first. So it's a hard problem, right? Making backward compatible kind of iterations and changes in APIs, that's a problem on any API. And then you mark something for as depreciated, and then you still keep it on, and then you tell the user, now it's really, really depreciated, and at some point you give just an error, right? But I mean, that's a hard problem to solve, and to solve it in a way that the user understands and understands why, and that it makes sense. I don't have a ready-made perfect answer to that. I guess it's having the kind of extensibility of the Kubernetes API in itself, and then having the parameters, and of course they have to evolve over time. And then there will be a new use case which kind of breaks an old use case, and then you have to kind of either make a breaking change or you don't do the new use case, right? So that's there's not that much that I can tell you there. On the debugging part, I don't have that many. Personally, I don't have that much experience with debugging the thing in production myself. So there I would have to refer you to one of our people that actually write the stuff and run it, and also run it in production. Thank you. And with that, enjoy your lunch. I heard there was a burger sponsor. Is that now for lunch, or is that in the evening? That's an important question, but let's see which one it's going to be. Thank you.